Hello, welcome back to Cracking the Cryptic and another puzzle by Panther today. Panther supplied our January reward, which was off by one. Fantastic collection of puzzles with Japanese sums and off by oneness about the clues, and it was great fun. And that was January, but February is, of course, the Skunkworks Duality 3 pack. It's absolutely fantastic, and we're very grateful to Skunkworks for sending that to us. The puzzles all feature lines with dual purposes, and they are most amusing. We think you'll enjoy that a lot. Do join us on Patreon if you haven't already, and if you have, give that pack a try because it's great fun. Just cherry pick some puzzles and have a go at them, even if you're not going to try and solve the whole pack and enter the competition and try and win yourself a collaborative solve with Simon. And of course, there's plenty of other things to engage with on Patreon, including connections videos, crossword videos, difficult cryptics, and gridogram as well. So loads going on there. Join us on Patreon. Try our apps as well. We have a killer Sudoku app. So if you like this puzzle, which is straight killer, you will like the Killer Sudoku app, and the latest one is Classic Sudoku 2 with some very interesting tips and techniques in the hints. Have a look at Sam Cappleman-Lynes' exceptional puzzles if you get that. And of course there's the Worms, and they are brilliant too. But let's have a look at the rules for Cornered in the Nines by Panther. Normal Sudoku rules apply, so 1 to 9 will go in every row, column and 3x3 box. Digits in a killer cage must sum to the digit shown in the cage. And they cannot include repeats. So, yeah, I've got to make sure that the version you can load up says that, because it is a rule. Right, that's it. So it's a partial killer. I remember the puzzle editor of the Wall Street Journal, when we suggested having a number of puzzles which were killers but didn't fill the whole grid, so they were different from other newspaper killers. He was saying, well, doesn't that mean they look inferior? I mean, I just don't think so to anybody. To me, it means they look better, but maybe to others, it means they look inferior. I don't know. To a layman, does it look better to have the grid completely filled with cages? I don't see why. Anyway, give this puzzle a try. Let's get cracking. Now, there's a lot of 9 cages here. Oh, but first of all, let's observe the beauty of the fact that all the cages are 3-cell L shapes, pointing one way or another. But a lot of them are 9 cages. There's quite a few 15 cages, but lots of them are 9 cages. There are 3 flavors of 9 cage, and I'm just wondering, what is a flavor? It is the makeup of the digits in the cage. That's what I'm using the term to mean. So you can have 1, 2, 6, you can have 1, 3, 5, or you can have 2, 3, 4 as the flavors of a 9 cage. I'm wondering if we're going to be coloring against each other. No, I tell you what we might be doing. We might be looking at the fact that there are rows and columns with 6 9-cage digits in. So look at that. Sven's magic means we can just highlight all the 9 cages by pressing down on the button while we're in one of them. Now, the digits that can go in a 9 cage, based on what I was just saying, are 1, 2, 3, 4, 5, or 6. The digits that can't go in them in this row, and let's colour them a different colour, orange, are 7, 8, and 9. And in that column, and in column 8, and I bet in row 8, all of these orange digits are 7, 8, or 9. And these will be, right, the interesting thing about those 3 flavours that I was talking about of 9 cage is that one of them contains a 6. One of them contains a 5 and one of them contains a 4. All of them contain 2 of the lower digits, 1, 2, or 3. But 2, 3, 4 contains a 4, 1, 3, 5 contains a 5, and 1, 2, 6 contains a 6. And that means that these are the 3 flavours going down this column, because one of these digits is a 6, one of them is a 5, and one of them is a 4. And that means that the offshoot digits that aren't in column 2 from those cages are from the digits 1, 2 and 3. They must be the lows because the middly digits go in here. Now that's going to apply in this row too. These digits are the lows. It's going to apply in column 8. These include the middlies, so these are the lows. And it's going to apply in row 2. These are the middlies, so these must all be lows. And we've even got, I've just noticed we've got row 5 and column 5 that I could orange as well and do the same trick with, I think. So these must include the 3 middly digits, and these are all lows. These must include the 3 middly digits, and these are all lows. And now look, we've got 1, 2, 3 triples all round the grid. So in column 2, we need a 4, 5 and a 6. Same in column 5. We could even, sorry, I could colour all the orange, I could number all the oranges with 7, 8 and 9. I'll tell you what I'm going to do with these 4, 5s and 6s now, is colour them a different colour. Well, let's, I thought this was going to work if I, yeah, look, I can highlight them by choosing the other mode, the pencil mark mode. So if I make them middly colour yellow, now where are we now? Oh, look at these little 15s and 14s trapped inside. It's beautiful, this, isn't it? I don't quite know how the magic is going to continue. We're going to have to find something out about these 15 cages. Are there any of the white cells that see all 3 oranges now? Or indeed all 3 blues? I don't know. The trouble is I might have to think about what the blues represent to work that out. The 15 cages, they must always contain one high digit. No, that's not true. If they were 4, 5, 6, they wouldn't need to contain a high digit. I was thinking they're always going to be one low, one middly, or one high. And I think the exception to that case is if they were 3 middly digits. And I don't know, I could even be wrong about that. I love this framework, but I don't quite know what to do next. I kind of want to colour things against each other. It's going to be something to do with how the 6, for instance, takes 2 and 1. If that was a 6, these would be 2 and 1. You couldn't have 3 there. I don't know how that plays out. I don't know, something must be fairly obvious at this point. I mean, I suppose because these are one of each middly digit, these 6 blues are going to be 2 of each low digit. And therefore, if that's a 1, 2, 3 pair, I was wondering about this earlier. Yes, this is very interesting. That's absolutely right. Okay, that is 1 of each yellow digit. So that's 4, 5, and 6. Because 4 must be accompanied by 2, 3, 5 by 1, 3, and 6 by 1, 2. These are 2 each of the digits 1, 2, 3. We know that's a set of the digits 1, 2, 3. So now we know that is a set of the digits 1, 2, 3. And we're going to find those everywhere. And they all see something. So here, these 3 all see these 2 cells, which cannot be super low. They cannot be blue now. They can't both be orange, because that would be too many oranges in box 5. I'm going to come up with a new colour for these cells that these groups of 3 that I've invented see. That cannot be 1, 2 or 3. Again here, So they all see these ones, and down here it's those three. Oh, there's more. There's 6 of these. There's another one. And I've missed one going up and down in the middle. Those 3 are 1, 2, and 3. So this one can't be a 1, 2, or 3. Now we've only got one place left for 1, 2, and 3 in the middle box. Now I didn't quite see that coming as a result. That's quite strange. And what are these grey digits? The trouble is they could be a high digit, 7, 8, or 9, or they could be 4, 5, or 6. All I know is they're not light blue. So I found one of them here. Okay, now I do need a high digit in this column. In this box, in this cage is what I'm trying to say. Because once I've got 1, 2, or 3, it's not a 4, 5, 6 set. And now I must take one high digit at least. I can't have 2 because that would already add up to 15. So I get one high digit here. And that is going to complete the set of 3 high digits in this column. And that means this can't be high. This is middly or low. That's not really everything, is it? I don't know. This is so interesting. I'm so pleased to have found this. And yet, what's its relationship to that? If that's a 6, this is a 2, 1 pair and that's 3. If that's a 5, this is a 3, 1 pair and that's 2. If that's a 4, this is a 2, 3 pair and that's 1. So this is always 3 less than that digit. That's weird, isn't it? I mean, I don't know if it helps. What's going on with these? One of these is high. Is that the interesting thing, or is it not? I just don't know. Oh, one of these 2 is low in row 4, and one of these 2 is low in row 6. Now that's going to form an X-wing, because we're only allowed 3 lows in each row. So it's either those 2 that are both low, in which case those 2 would be, I was going to say both middly. No, I don't know that. Or those 2 that are both low. Oh, which is a huge cluster going on here. No, this can't be low. This can't be low because we'd have 2 lows in the 15 cage, and that digit would have to be at least 10. So the only place for the 3rd low in this row is there. Oh, interesting. Now this can't be low. Oh no, hang on, we can have 2 lows in a 14 cage. This cage is not a 15. Oh, bother. Well, that ran out. But these are all low. So I can colour this grey, and now that must be low in this row, because we need a low. And now this is, well, obviously this is not low. I'm going to colour it grey. Grey means yellow or orange, weirdly. Now, this digit can't be low because then we would have 2 in a 15. It's not a 14, don't panic. So if that can't be low, this is the other non-grey digit in this box. So that is low. Now this can't be low, or that one, and this is low in the column. Now we really do have a cluster going on here of blues. Oh, this is weirding me out. This cannot be low because it's a 15 cage, so that's grey. Now, again, it feels like progress, but weird. Again, there's this relationship of a difference of 3 between those 2. That must apply between those and between those as well. Should I think about the 14 cage now? The 14 cage definitely doesn't have 2 highs in. But it could have 2 middlies. It could be 6, 5, 3. Well, let's just think about this central box. Of these 3 cells, 1 is high and 2 are middly. Does this 15 cage need a low digit? The only alternative to that is a triple middly. I don't know, I can't rule that out, can I? Now, one of these is high, because this 15 cage has got a low in it. One of those has to be high, and that's going to be the third high. Now we know that these two greys are definitely yellow. No, this is a 14 cage. I cannot say that one of these has to be high. I want to, but I can't. These are a middly and a low. And whatever that is therefore going to be the same nature as that. Am I really making a filthy pig's ear of this? I just don't know. I just don't know. There's something about these L-shaped cages that's driving me crazy now. These could both be middly. They can't both be high. At least one of them is middly. Is that not any use? It's not really, is it? One of these three, exactly one of these three is high. Whichever one it is, it's got to put a low. No, I was going to say this cage needs a low. Again, I've been suckered into that. It could be three middlies. It doesn't need a low at all. I'm going to have to colour the 1, 2, 3 digits against each other somehow, but I don't know how to do this. I mean, yes, maybe I do. Maybe I do. If I call that one a red 1, 2, 3 and this one violet. This one is the third colour, so we'll call that green. Now, violet forms a trio with those two. So they're red and green. So in this column, that is violet. Now these two are red and green. This one can't be red, so it's green. That's red, that's green, and we can finish off these colourings in the column. And much good may that do me. So this shade of yellow goes with violet and red. I don't think I can take this into the rows, annoyingly. I mean, it's true shading for the columns. But I don't know what it means for the rows. Oh, I'm feeling thoroughly inadequate. These two must include at least one middly digit. Or a 15 cage with a green, no, this is the only 15 cage with a green flavour in it. Sorry, I thought that was a 15 cage for a moment. This cage doesn't have a green flavour digit. No, I don't know that. Green is a 1, 2, 3. I'm sorry, I'm losing my mind now. Do we know that this is a set of 7, 8, 9? Now that's interesting. There might be a way in which we do. Then I would know that this was yellow, if that was the case. Okay, that's... Why would they have to be from a set of 7, 8, 9? I'm sort of thinking that these 6 cells in columns 4, 5, 6 might have to be 2 of each type. but I don't know what that's based on. Sort of a general feeling about symmetry is what it's really based on, which is not an answer at all. I bet in the final solution they are a set of 7, 8, 9, but I don't see how I'm meant to be able to prove that at this stage. Okay, what I can definitely say is that that is one group of 7, 8, 9. That's another, that's another, that's a fourth. This one is a fifth in column 5. This one is a sixth in row 5. So in this puzzle, in which I have highlighted 18 orange cells, there are 6 of each type. There are 6 7s, 6 8s, and 6 9s. If it happened that these two, no, which two? I'm trying to prove those 3 are different from each other. If those 2 were the same, that would be the same digit. Now, how could I know that wasn't true? Perhaps. One of those 2 would be that digit. One of those 2 would be that digit. I don't know. I bet there is a way of proving that, but I'm not sure I can work it out. I'm going to have to do something clever or different. My colouring of 1, 2, 3s really has not paid off. I did learn that there was a relationship between the yellow in each of these boxes and the blue that isn't in the cage. The yellow is 3 more than the blue. What does that do? It doesn't really do anything, does it? Oh, one of these 2 is the violet. 1, 2, or 3. So that's not violet and that's not violet. So I do get that that's violet. And is that in a trio? No, this is the weird one, isn't it? I could have got that just by looking at green and red there. This is the kind of extra cell. And so is that. And so is that. I mean, I've got extra cells in blue that I haven't. I've got more light blue cells than I have orange cells. And twice as many oranges virtually as yellows. Now, if this is violet, let's say this was red. This couldn't be violet because that would be a red-violet pair going with whatever digit that was, and that would appear twice. So if this is red, that's violet. However, if this is green, well then that's red and that's green. Yeah, I don't know what that proved. That didn't prove anything. Oh, goodness, I don't get this. I don't get this. I'm being very dense now. There's some brilliant holistic thing to explain the whole puzzle to me. Maybe it will go back to the fact that one of these is orange and is high, and one of these is orange, and the other one is yellow. If that was orange, these 2 would be yellow. And that would have to be yellow because once that's yellow, that's orange. So that started, if this was orange, that would be yellow. If this was yellow, that's orange. This is yellow. I don't know if it's a different... Okay, one of these is violet. Whichever one it is can't be going with green in these cells. That's interesting. Right, one of these is violet. Whichever one it is can't be going with green in its equivalent, in its cage, because that digit would have to be the same as this one. In fact, we know these are three different ones. These two are green and red between them. And the violet in row 8 doesn't go with the green in row 9. It goes with the red in row 9. And the green in row 9 goes with... That's what I was just talking about. The violet goes with... No, the violet goes with red in row 9. So the green in row 9 goes with red in row 8. One of these two is violet, and whichever cell it's looking at in row 2 has to be green. And not go with red at the top. Has to go with... I don't know. I'm not going to get anywhere doing this, because this just rotates around. There's no decision. The 14 cage is going to be the decisive cage somehow, and I haven't got a clue how that works. We're probably going to end up with both of these being yellow. Okay, so what would happen if this was orange? But no, that may not be the thing that happens. What might happen is this might be triple yellow. That might be the really interesting thing that could come to pass. Wow, I just don't get this at all. That's interesting. I'm just seeing violet here and here. We know that violet in box 9 is in one of those cells, and in box 3 in one of those. I didn't know we knew that, but we do. Just by Sudoku colouring, basically. I don't know what it means. It doesn't really seem to mean anything. That's violet. So one of these... Oh, so that's red and green. I had not figured this out. This is red and green. And in this row, in rows 4, 5, 6, we've had purple, red. We've had red, green. So this one must be green and violet. Ah! Oh, well, that's absolutely blindingly obvious now. So these three middly digits have to be accompanied by different pairs of the light blue colours. Violet and red there. Here it's obviously red and green in some order. And therefore over here it has to be... I can't even work it out again. I've just said it. It's green and violet here. And that means that one is not violet and that one is. This is red to complete the 3 in this box. That is now not red, and that's not green. Right, so at least I managed to extend to these positions. Now, can we get that going north somewhere? Oh, yes, we can. This cell is part of this triple, so it's not violet, and it sees green, so that's red. This now sees red and green, so it's violet. Yes, this is going to do it. Well, it's going to do something. That's red to complete the trio in this row. That sees red and violet, so it's green. That's red. This is violet to complete the trio. This sees violet and red, so it's green. This is violet to complete the trio. So that's coloured all my light blues. Now, violet, violet, violet can't go here, so this is violet. in column 3. That's where it must be. And now that's all the violets marked in the puzzle. I've got a red there to complete the reds. I've got a green here to complete the greens. Intriguing. Okay, that is something. Now, what's more is that red and violet go with a specific yellow. Let's call it yellow-grey. I'm going to get rid of all the greys. Let's call it yellow-grey. Red and violet always go with yellow-grey. So there's another one. There's another one. Let's deem that violet and green go with yellow, dark blue, which is there, there, and here. And the other one is just plain yellow. Maybe, oh, that's crazy. Can't leave it plain yellow. I'm going to have to call it yellow pink. So these are all the same. And we now know these flavors of the cages that I was after at the very beginning. Now, we found more 1, 2, 3s. We know that is orange and yellow, don't we? Yes, we do. So these two are now yellow. And that's all 3 yellows. So that's orange. Now in this row we need 2 more yellows. This is great. This is great. We've got all 3 yellows there, so this is orange. Now this cage has got light blue and yellow. It needs orange. And that is the last orange in this box. And these 2 are now middly digits. And this one is the exciting cage that has become triple yellow. Once 2 of them are yellow, it's definitely a 4, 5, 6 triple. Now, this cage, I still don't know. This cage, that was 1 of each. I've got 2 of each in that row. Okay, how am I going to use this 4, 5, 6 triple? Can I identify the colours of yellow? Oh, that feels like a really weird question. I don't think I can, since I've only got the colours of yellow in the framework of rows 2, 5 and 8, columns 2, 5 and 8. You're not seriously telling me I'm going to have to colour 7, 8, 9s against each other now. I can't get my head around that. I don't want to do it. I'm scared. But it might be what has to be done. What about the 15 cages? I've got 1 which is triple yellow. I've got 1 which uses the red 1, 2, 3 and 1 which uses the light green 1, 2, 3. And the 14 cage. Now this could still be double yellow and a 3. In fact, I rather think it's going to be, because that might be how we achieve disambiguating things. But if this was high, and a 7, 8, 9. What then? I don't know what then. I don't know. Can I... this is yellow and orange, 1 of each. Right, this can't be yellow. Oh, hang on, it could be. I was going to say, because these can't both be orange, but that's not right anyway. 1 of them is going to be light blue. Oh, well, that's definitely true. 1 of these is going to be light blue. Is that any use? It's going to be green. This one sees all the colours of light blue. Goodness me, I hadn't noticed that. It sees green, red and violet. So that's not light blue. So in this column where we need another light blue, it's there and it's green. Well, that's interesting. Oh, I hadn't finished off greens. I should just have done that Sudoku. Now, 1 of these is yellow and 1 is orange. Whichever one is yellow is the same as that digit. This isn't getting any easier. It's all about this 14 cage. This is the one that's breaking us up. If this was high, I want to say it couldn't be 9, but actually it could. 941 would still work. That's weird. This is 4, 5 or 6. It's grey or blue. Oh, these aren't grey. The yellow-grey in this column has to be in this box. And therefore this is yellow-pink. I hadn't realised that. Oh, I should have done. I could just have worked that out from these. Okay, but that must now be yellow-pink. That's where it goes in row 7. And then it's in one of those two cells, and I don't know which one. But still, I still feel I learnt something briefly there. Yellow-grey is in one of these cells. One of these is yellow-pink, so one of these is yellow-pink. But the colouring on this puzzle is just driving me mad now. Okay, that's yellow, so one of these two is orange. Is that any use? Probably not. Probably not. What about comparing the 15s? I mean, it just doesn't work because I don't have common digits. I mean, obviously that appears somewhere in this cage because it's yellow and this has got all of the yellows. But once you've said that, I don't know where you step away. My goodness me, I don't get this puzzle. Keep making tiny little breakthroughs and thinking I'm on the crest of, on the cusp of something. And I'm never on the cusp of something. There are very few orange cells in cages. There's going to be one here. There is one there. And there might be one here. Now, can we work that out? That would be quite interesting if we could. Right, there's exactly one orange cell in this row to go. Then in this row, there's exactly one to go. And in this row, there's exactly one more to go. That's going to be 2 oranges in these 2 rows that we still have to place. One of them is definitely in this cage. If that was another one, then these cells are both orange. Yeah, I don't think this works. If this was orange, this cage that needs an orange has to have it here. Then these are both yellow, and these 2 boxes need 2 more oranges. Like, somehow that doesn't work. I'm right. And I should have been able to see it more clearly given the original questions. I didn't, but nonetheless, I am right. This can't be orange because this cage needs an orange. Its orange would have to go there because all 3 would be done in this row. If that was orange as well, these 2 would be yellow. And these 2 cages... No, hang on. This is okay. If that's orange, this is yellow, and that's orange. Okay, that did not work. That nearly worked as an idea. If this is orange, that's orange. Right, now I have to find another problem with that. I'm not sure I'm going to. These are both orange. These are both yellow. But this cage is then done, this box is then done on yellows, and this one isn't and needs another one. That is my problem. It would get, the column would get its third yellow here. That would be yellow to make the third in the box. So something about the colouring of these blooming yellows. I mean, I haven't coloured enough of them, maybe. Grey is going to have to be in one of those two. That's not enough information. If grey was there, grey would be in one of these two cells. Oh, here's something. The yellow digit in this cage is grey. But the trouble is, I don't know which box it's in, but it is grey because it forms a trio with those two, just as that one does. So this is going to be green and grey and some orange digit that goes with those. I mean, it's interesting. Isn't it? Maybe not. Maybe it's not. But yellow-grey is in this cage, along with blue-green. Yeah, okay. So is there another cage with blue-green and yellow-grey? No. When yellow-grey gets in a 9 cage... This pair is yellow-grey and blue-green, and they're 3 apart. So when yellow-grey goes in this cage, along with blue-green, that's either 3, 6, which would need another 6, not possible, 1, 4, which would need a 10, or 2 and 5, and that's what's going on. So one of these is yellow-grey, and that digit is a 5, and this digit, blue-green, is a 2. This is extraordinary, but that must be what's happening. Oh, goodness me, I'm knocking things over. Oh, I'm knocking things over again. My mouse has got tangled. Right, I'm doing blue-green as a 2. Because it is. Because of this relationship of 3, the difference. Not only that, this pair is now 2, 5, 8 to make 15, isn't it? I mean, that's 5 and 8. So these digits, these cells can't have an 8 in. In fact, 5 is the grey digit. 5 is yellow-grey. Right. So this pair, don't know. I know that these two are 1 and 3. Oh, I knew that before once. I'd made green 2. That's, hang on, I've totally put that in the wrong spot. There's the 2, right. Very tempted to get rid of the green colour there. And obviously in all of the other things, we're not having a 2. There's another one. They're all 1, 3 pairs. And we've found that grey is a 5. That's going with the 1, 3 pairs. So these pink and dark blues are not 5s, including that one. So one of these two is a 5. And the other one is 7, 8, or 9. Now, how do I use that? I don't know. Now, one of these is 8 in this box because that isn't. And now that can't be 8. So now one of those two is 8, and one of those two is 8, and that's an X-wing. That's going to use up the 8s in rows 6 and 7, and these can't have an 8 in. So that's a 7, 9 pair, and now this digit is an 8, and that one's not. And now in, oh no, I was going to say there must be an 8 in that column. That's not necessarily true. That was interesting progress. It didn't last. If that was a 1, this is either 9, 5 or 8, 6. I don't want to think about that. Oh, one of these two is grey. Yeah, that's no help. If it was here, these two would add up to 10. That's easily done. This is not. This is a 4, 6 pair. Oh, look at that pair. Now, that is odd. This is even. The total of the cage is even. This digit is going to have to be odd. And it's not 1 or 3. It's 5, 7 or 9. Now, annoyingly, that is not a colour. That is a number. What on earth does it mean? 5, 7 or 9 here. Okay, if this was a 5, that would be 6, 3. If this was 7, these could add up to 7 in 2 different ways. And if that's a 9, that's 4, 1. Bother. That's not a 2. In this column, we've had a 1, 3 and a 4, 6 pair. And a 2. Oh, goodness me. I thought I was getting somewhere. Oh, 7, 9 pair there. 2, 1, 3. These are from 4, 5, 6, 8 only. Is that any use? No. It's just not. Or is it? No, it's not. Oh, goodness gracious. Right, how did I mean, I got this 8. Oh, that's a 4, 6 pair. And that's not doing anything, is it? It's not doing anything. It's just like filling in the gaps. They are blue and pink between them. This was 2, 5, 8. This is 4, 5, 6. One of these digits is a 5. I haven't really focused on that yet. It means that can't be a 5. That's not an 8. One of those two is. One of those two is. The other one is a 5. I don't know what that means. Oh, Panther, you are messing with me now. Okay, if this was a 5, they would both be odd, and this would have to be odd as well. If this was 4 or 6, that would be even. That would be 8. Now, what would happen to 8 then? I'd be finding some 8s in the grid and not others. I don't know what that means happens to 8s. Again, I don't know. Can this be a 5? It would be brilliant to rule it out. Oh no, I looked at that. These two just have to add up to 10 then. If that's a 5, this would be a 4, 6 pair. Yeah, that's not getting me anywhere. We've placed 2. This is either 3, 4 or 1, 6. That's not, this can't be a 5, that's all I know here. That's not getting me anywhere either. In this row, I need 4 and 6. Oh, one of them is there. The other one is definitely here. Hadn't seen that before. And it's not the pink one, it's the blue one. And we've got blue there. Blue and pink, 4, 6. This digit is 5 or 8 down in the corner. And that's a weird 5, 8 pair. That digit reappears here. Ay, ay, ay. 5 or 8. Oh, I don't know what it is. I don't know whether it's high or low. That's what I really want to know. I think the puzzle will finish if I know which of those is 5 and which is 8. I really think it will. But we're 47 minutes in and it has not finished. 1, 3, 2. Goodness, one of these is 8. Why is that no help? I don't know. One of these two is 8. Now, I need to find something offset. That digit, which is not that, is the same as this. These two are the same high digit, 7 or 9, and it appears there in box 7. What I need to do is find different 7 and 9s pointed at the same cell. I'm going to literally have to colour 7s and 9s now, am I? That's one set of 7s and 9s. That's the other one. So those two are different. They're different. Oh, that's not what I want. I want them to be the same. That would be incredibly useful. They're not. Okay, so I'm going to have to go with letters because I'm just getting utterly confused by the colours if I go with any more colours. So let's go with letters. This one is A, that's B. This is just 7s and 9s that I'm doing now. That's A. This one's B in the column. That one's A in the box. This one's B in the row. And now this sees A and B, and they're a 7-9 pair. There we go. Bingo. That is an 8. I mean, this is A now. Come on, this might help. It might not. One of those is, this isn't A or B, but is it high? No, this could be 8, of course. Come on, 8, do something. Yes, you're doing something. You're telling me this is 5. That's what I wanted to find. So this is 8. Right, that's what you're doing. This is 5 and is yellow. This is corner 5 and is yellow. I claimed that this would finish the puzzle, or might do. That is 5 now in row 7. And that is in this cage. So we've got 2 yellows in the cage. They have to be 5 and 6 with a 3. And now we know that this purple colour is a 3. Violet is a 3. There we go. So we know that this red colour is a 1. And that this is now a 6 to make up the total in the 9 cages in which it appears. That's the pink. This is a 4, the dark blue that we had. I should get rid of those colours now, shouldn't I? Sorry, I'm just trying to tidy up the colours so they don't obstruct me anymore. Get rid of the grey. On these 1s, I can get rid of the red as well. I think we've done all the 1s. Right, now, this digit is not 1, 2, 3, 5, 6, or 8, or 4. So that's 7 or 9. And this is now 8. I might as well orange that. Sorry, I didn't manage to get rid of the pink on the 6s somehow, even though I thought I was doing it. There we go. This is a 4. That's a 5 in the box. That's a 6 because it sees 5 and 4. That's a 4 to make it add up to 15. This is 4, that's 6. Finally, this is 5, that's 4. All the yellows that I've already depicted are done. There's a 6. That's going to have to be 4. And we need a 5 in the corner again. And that's all the middly digits done. Everything else is going to be high. So I've coloured the whole grid. Hurrah. Now I have to do some number crunching in this cage. Is this the only one? Yeah, I've got a lot of 8s already, and this is going to tell me a 7 or 9. 5 plus 1 is 6. That's a 9. Right. I'm deeming that that is going to help. Although I don't quite know how yet. We get rid of 9 out of those cells. Oh, and 8 is looking at that cell. So that's 7. That's 8. This is 9 in the row. That's 7 in the row. This is going to help. Yes, it is. That's not 8. That's not 8. And these aren't 7s. And down here, there's a 9 in one of those cells. Oh, this digit in the corner is 8 because of the column. That's 9, 7, 8. Up here, one of those two is 9. So that's not 9. I mean, my goodness. Have we got any other cells in cages? No. This has to be Sudoku for the rest. I've got A's and B's go. Oh no, look, I've got an 8 there looking at that. Right, straightforward, thank goodness. 9, 8, 7. 9, 8. B is 9, A is 7. I have finally learnt. And there we go. What a magnificent puzzle. That is just evil and clever and brilliant and hard and intriguing. Well done, Panther. That really is quite a tough solve. And I'm sure there are ways of doing it better. I'm sure there are. But thank you for following me on my long and winding route to a solution. We'll see you again tomorrow. Bye for now.